Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aliff Adan bin Jamal. Matric ID number B071710819. My supervisor for this project is TS Dr. Ahmad Fuad bin Abdul Ghani. The title of my project is Study, Development and Fabrication of Low-Cost Air Ventilation Smart System for Residential and Small Medium Office Prototype. Okay, firstly, I will explain for the background of my project. Over the last century, technologies such as heating, ventilation, and air conditioning HVAC and thermoelectric effect have undergone significant developments. Thermoelectric effect has taken its place in areas such as cooling and ventilation from windows packs to energy efficient, tightly regulated, and economical devices. These methods are always progressing. Okay, chapter 1, introduction. Firstly, I will explain my problem statement. For the first, air conditioner consume higher cost for installation in the building or room. Secondly, most of the building using air conditioner, which is consume higher power consumption, high electricity bills. Thirdly, air conditioner for ventilation system give effect to environment due to emission of chlorofluorocarbons. Okay. Objective. My objective for this project is to fabricate a low-cost air ventilation system of working HVAC model using TEC, Peltier. Secondly, to study TEC as a substitute for the existing HVAC system, which overcome all the demerits of the current HVAC system. And lastly, to test HVAC using TEC for its effectiveness, efficiency, environment friendliness, comfort, and convenience. Okay, the scope of research. This work mainly focuses on giving a solution to occupant related to trapped heat in residential and small medium office during daytime. This project uses the Peltier as the main element to reduce and ventilate hot air inside the small medium office. Secondly, to research and design low cost of air ventilation system and providing comfort to residents with a good thermal comfort. Next, chapter 2 for the literature review. From the Outer Guru Prasad YK 2018, we find that the energy that is the Peltier impact the power to cool the specific area. From the Satyam 2016, we find that its cooling capacity is equivalent to the wall air conditioner and can be easily transferred anywhere. From the Rifat 2003, the environmental legislation and the issue of chlorofluorocarbons (CFC) are sufficient for the time being. Okay, next, chapter 3, methodology. These are my methodology chart. Okay, these are my selected design. I use the CAD 3D SolidWorks to design the casing of the ventilation system. Okay, for the manufacturer selection, these are material that I use for the project. So these are the cost of my material product. Okay, for the equipment for taking the result. From the first picture, these are my friend's project, which are to determine the temperature and relative humidity. These are the sensors. Secondly, the second picture is the anemometer. The anemometer is used to calculate the velocity of air. Okay, for the project development, these are the picture of my project development. Okay, chapter 4, result and discussion. There are two parameters that are taken for the result. Firstly, temperature in degrees Celsius, and secondly, the relative humidity in percent. Okay, so these are my experimental results. So these are my result graph. The graph result before the product switch on. There are two graphs. First, temperature against time, and secondly, temperature with relative humidity against time. In the early 3 minutes, the result for temperature before the product switch on is 27 degrees Celsius, while the relative humidity against time, the result of relative humidity is 42.8%. So, after the 50 minutes have been passed, the temperature result is 26.8, while the relative humidity is 43.7. From this, we can we can see that there are change in temperature and relative humidity. Okay. That the temperature is affected by the environment and surrounding. For the relative humidity, the range are in 30% to 50%, which are in the best ideal humidity comfort. For the At the end of the 30 minutes, the temperature is 27, while the relative humidity is 40.9%. So the result graph when the product switch on. In the early 3 minutes, the temperature against time is 30 degrees Celsius. The temperature while the relative humidity is 41.8%. Okay. After the 50 minutes have been elapsed, the result of temperature is 25.5 degrees Celsius, while relative humidity is 35.7. This, we can see that there are the different temperature in the early 3 minutes and after 50 minutes. The temperature are decreasing from 30 degrees Celsius to 25.5 degrees Celsius. This is because when the product is switched on, the ventilation is recirculate in the cooling areas, which are the cooling air is produced from the peltier and being blown by the CPU fan over the heatsink cannons. Okay. At the end of the 30 minutes, the result achieved 23 degrees Celsius for temperature and the result for relative humidity at the end of 30 minutes is 33.3%. Okay, we can see that the result of temperature are decreasing against time. We know that the cooling areas in time from 0 minutes to 30 minutes are decreasing for temperature. It shows that the storage box or cooling areas are being cooled against the time. For the relative humidity, at the end of the result, 30.3%. It shows that the relative humidity in the best ideal range, thermal comfort which are from 30% to 50%. Okay, next for the discussion for the thermoelectric module peltier that I choose. The one ceramic plate is cool and the other is heated by applying a current to it. Secondly, the direction of the current is determined by the cool layer. Secondly, the cold side peltier is multiple times cooler when this device is used to get the final temperature of the air needed. The second parameter is the heatsink efficiency between the peltier hot side and the atmosphere. And lastly, delta T is the difference of temperature between the hot and cold side of the peltier. Okay, for the discussion of cooling load, the amount of heat to be removed are consumed, which is QC by the cold side of the TEC. Okay, next, the thermal resistance. The key parameter of the hot sink for the selection process is the thermal strength. The coefficient of performance COP also been calculated in this project. And lastly, the power supply. Okay, these are my calculation. The calculation of heat absorbed by the Peltier cold side QC. We can follow the formula of the QC equal to M multiply by Cp, specific heat air, and multiply by the delta T different temperature. From the anemometer, we get the velocity of air is 3.0 meter per second. Okay. From that, we can calculate the QC by insert to the formula. The result for the QC is 154.23 watt. For the heat discharge from the hot side of TEC QH, the result is QH equal to 334 watt. For the thermal resistance RT, it been calculated. The result for thermal resistance is 0.01198 Kelvin per watt. For the coefficient of performance COP, the result of COP is 0.9778. This is the important calculation in this project because we want to know the heat absorbed by the Peltier and heat discharged by the Peltier, which are from the cold side and the hot side. For the thermal resistance, we calculate from the heat sink resistance. For the coefficient of performance, we can know that this Peltier is the best performance, which are 0.9778. Okay. For the calculation of power consumption by the device, for the Peltier, the current of the Peltier I use is 10 ampere, while the voltage of the Peltier is 12 volt, 120 watt. From the CPU fan, we can calculate that the power consumed is 5.04 watt. From the CPU cooler, we can calculate the power consumed is 2.4 watt. So from this, total power consumption is 127.44 watt. Okay, next in the chapter 5 for conclusion and recommendation. For the conclusion, this prototype thermoelectrical air conditioning has been developed and installed so they can be used to cool the room personally. TEC has been used to achieve cooling by inverter with an AC to DC power supply. Test finding revealed that the cooling system would cool the air with the CPU fan by recirculating the air within the storage cache or cooling areas. The design TEC cooling enabled the system enable the air in the room to cool down from 30 degrees Celsius to 23 degrees Celsius that are measured in the result. From this, we can know that the different temperature of in the early 3 minutes and at the end of 30 minutes is by 7 degrees Celsius. All the project elements were independently tested and the findings were found to be positive. Okay, for the recommendation, in terms of quantities, the use of Peltier can be applied to this project with the heat sink to make a significant effect on the entire scheme. As the amount of Peltier with a heat sink is applied, it can increase the heat transfer from the Peltier, which serves as a cooling system and can improve the heat absorption efficiency on the cold side of Peltier. Therefore, the time needed to exceed the ambient temperature can be increased. It can be replaced with a better heat sink on cool side with rolling channels or pipes to drain air for a longer period. As an alternative to the usual CPU fan that used in this project, the cooling system will have greater ventilation if a blower fan is chosen. Okay, that's all from me. Thank you.